Hello friends, good afternoon and welcome to the EduSat Network. Our topic of discussion is second part from yesterday. Friends, we had been talking about climate and controlling factors, and this shall be a continuation from yesterday, where the focus shall be on two factors, that is wind and moisture in particular. And for this very discussion, we have thus in our studio our same subject expert, Dr. Anju Singh, Assistant Professor, Department of Geography, Aditi Mahavidyalaya, University of Delhi. With this brief introduction, I welcome ma'am to our studio. Thank you ma'am for coming.
Thank you Vasiji, and dear viewers, very good afternoon to all of you. In continuation my yesterday lecture on topic climate and controlling factor, today I take up two more other factor, wind and atmospheric moisture. As we know, Earth system is a very complex, and their climate of any part or any region is not so easy to understand. These are very interactive processes between atmosphere, ocean, continent and earth system, all channelized by our solar energy. And wind and moisture play a very important role to regulate this imbalance created by the atmosphere of energy and pressure. They supply and equalize whole surface, so they have very important role in shaping characteristics of a climate. Global heat supplies through water and its three phases have tremendous capacity to either absorb or release heat, and it acts a powerful control of global climate. Because in any climate, moisture have play a very important role. Moisture have play an important role in form of rainfall, storm, etc. It is all these things depends on amount of moisture. So first I take wind. Wind is the motion of air molecules with respect to the earth, and it's dominantly horizontal. Wind is the motion of air molecules. It may be in any direction, but horizontal motion is more considered powerful than the vertical motion. Wind develop as a result of special differences in atmospheric moisture. Whenever is pressure gradient exceeds and pressure change, the air molecules tends to drift or move some direction according to a gradient. Winds generally blow from high pressure area to low pressure area, and wind speeds tend to at its greatest during the daytime, because the daytime the greatest extremes are exist. There are not only pressure, because other forces which act in modifying of wind origin, wind motion, wind speed, and these forces are known as wind controlling forces, and these are the pressure gradient force, Coriolis force, centripetal force and friction force. In this pressure gradient force is the primary force which act to blow, but other three forces, Coriolis, centripetal force and friction force, modify the wind direction and their speed and their change in speed. So the pressure gradient is primary force which modifying a formation to cause wind from global scale to local scale. Global scale to local scale according to their differences of pressure. The pressure this force exists whenever the pressure differences arise, and these pressure differences arise due to the uneven heating of earth's surface, as we already discussed yesterday in section of temperature. So it causes wind to blow by pressure gradient, as the force is directed from higher pressure towards lower pressure, and the magnitude of the force is directly related to the pressure gradient. Pressure gradient means the as we know in simple words, close spacing isobars indicate the high pressure gradient, and high pressure gradient as arise wind speed stronger force, and then speed automatically high of any place. Steep pressure gradients correspond to the strong force and vice versa. Another force is the Coriolis force. As move things and rotating earth, all moving water, fluid and object are affected by the Coriolis force, and it is described an apparent force that is due to the rotation by earth. It is a force causes the wind to deflect the right of its path in the northern hemisphere and the left of the part in the southern hemisphere. The magnitude of this force varies with the speed of the wind and latitude. As the wind speed increases, the Coriolis force increase, and thus the greater is the deflection. Coriolis force increase for all wind speed from 0 at the equator and maximum at the pole. This graph shows the relationship between Coriolis force, latitude and their speeds. We can see in this as move from equator to poles, speeds of any magnitude increase. So, at 0 degree equator, the Coriolis force of 0, and as they and highest on the 90th degree. So, Coriolis force change according to latitude, and it is higher on 90 degree and lower at 0 at 0 degree. Next force is centripetal force. This is a force only the force which change the direction. This force act in the air. It is not active on lower atmosphere or earth surface. It is active in upper atmosphere. Centripetal force is responsible for continuous change in direction, not change in speed. It act only air that flowing around center of circulation. This force produces circular pattern of flow around center of high and low pressure area. Next, friction force. Friction force is a force which act in a lower atmosphere, and this force act as a change and slow down the wind speed. The friction force of the ground slow down the winds, and atmospheric layer influenced by friction called the friction layer. Usually extend upward at an altitude near 1000 meter above the surface. Friction reduces the wind speed, which in turn reduces the Coriolis force, and thus the weaker Coriolis force no longer balance the pressure gradient force. So, these are the forces some forces are regulate and format the wind, some are change their direction, some are changing their speed. So, all things are modifying the wind motion of earth surface. So, in atmosphere circulation, general circulation is a process by wind. So, this is the diagram of general circulation model, and this is wind play a very important role. The atmospheric motion may be vertical as warm air raise and became beyond. It can also be horizontal as wind generated by air moving from high pressure area to low pressure area. The tropic experience a net gain in energy, while polar regions suffer a net loss, and thus to balance these inequalities, the atmosphere transport warm air poleward and cool air equatorward. And this planetary rotation caused the development of 3 cellular sails are known as Hadley sail, Ferrel sail and polar sail. These are the location Hadley sail from 0 degree to 30 degree located in between the 0 to 30 degree north and south of hemisphere. Ferrel sail between the mid latitude at latitude is between 60 to 30, and polar sail at the pole. All sails are both in the hemisphere. Hadley sail is the Hadley sail formed when the warm air on the equator region rises by convection, and this rises air reach the tropopause, and then the air moves towards poleward. The Coriolis force deflect this poleward flow towards the right in the northern hemisphere and left in the southern hemisphere. As air moves poleward from the tropics, it continuously cooled by radiation, and at the same time it begins to converge. This conversion of air aloft increases near 30 degree of latitude of both the hemisphere, and the conversion of air aloft produce belt of high pressure which called a subtropical high pressure belt, which at 30 degree of latitude. From this zone suffer the air travels in two directions, because at the conversion air diverges from the different direction. A portion of the air moves back towards the equator and completing the circulation system known as the Hadley cell. Another cell is known as a Ferrel cell, and these suffer on the surface of air moving towards pole from the subtropical high is also deflected towards its producing the westerlies, and this air moving towards the poles meet the cold air from the poles. They separated by a boundary called the polar front, subpolar low, or a small portion of this lifted air is sent back into the Ferrel cell. After it reaching the top of the troposphere, it make a Ferrel cell in both the hemisphere, because wind has compensate to wind has very important role to compensate the water in the air of surplus area to deficient area. Next cell is polar cell. It is located on both the both the hemisphere at 90 degree. Air aloft along the polar front reach the poles and sink to create the polar high and flows back towards the polar front. This circulation cells of polar region is called polar cell. So, by this all these cells, a whole system of general circulation model actualize the temperature differences, pressure differences, and whole earth is annual and average pressure temperature maintained by each latitude through this circulation of atmospheric circulation of which is known as a general circulation. And this is also a figure by global scale circulation by through arrow shows the direction of movement of winds at actual land and sea. According to distribution of land and sea, heat we can see heat gain at equator, heat loss and pole, and this is the direction of circulation. Wind and ocean current play a very important role to this redistribution of around the earth. Ocean do not boil away near the equator or not freeze near the poles, because this circulation and this transfer of wind and ocean current from equator to polar region. This is also a general this is the flow map flow of flow chart of general circulation model. In this figure, whole processes are there. We can see at equator low pressure area, because in equator area heat up and sun gets more intense energy. So, there is a air rises in upper atmosphere towards up to the troposphere, and as move towards tropopause, it's cool down, and they have to divert in the direction opposite direction, and then sink at the 30 degree. So, ascent, descending, conversion or diversion, all the processes are play a very important role to transport or circulation of the air. Atmospheric circulation cell, this is also horizontal or latitudinal extension of 3 cell model, in which we can see how air arises from equator, then turn at the and then sink at 30 degree, from diverse from towards equator and from towards poles from 30 degree. Here process known as diversion, here process known as ascent. Here at the same these blocks are like a cells. This is the these both are Hadley cells in the both the circulation both the hemisphere. This is the map. In this map, the area located between marked between the 20 degree to 30 degree of latitude, because this area suffer from deficiency of water. In that latitude, air descending, and that is why this area face a problem of deficiency of water, because here is evaporation rate is high, but precipitation rate is very low. So, all the deserts are located in this zone, especially in western side of continents, and this situation is arise in both the hemisphere. So, world largest deserts are located here: Sahara Desert, Thar Desert. Prevailing winds are the winds which flow permanently on the surface from one direction in same direction. Air going from high pressure to low pressure is known as wind, and these winds also blow in the same direction. Prevailing winds always follow the same direction. Prevailing winds move around the earth due to the earth rotation, and this carries warm air from equator to poles. Prevailing winds moving over ocean carrying water to land and condense is called rain. And which winds carry water from ocean area, they are very moisture laden, and they flow whatever is area is create much of rainfall. This is also prevailing in this map show prevailing winds, and these are the primary winds which known as trade winds, westerlies, ITCZ. All these are shown in this figure, and their direction change according to Coriolis force. Here is also we can see air current, because in general circulation air currents and water currents and water both have important role. This is the simplest example of wind motion, and with easiest example we can experience every day in our life. In the coastal area, in daytime, it is a process known as land breeze or sea breeze. In the daytime, more intense heat available on land. It means land get up heat much in comparison to ocean area, because both have tendency to warm and cool at different scale. So, in daytime land surface experience low pressure area due to the high temperature, and same time in water area experience high temperature. So, winds move from high pressure area to low pressure area. It means ocean area towards from ocean area to coastal area, and then it is kind of opposite in the night time, because sun after the sunset land get up cool early, and here the temperature situation is changed. At land area temperature is low in comparison to ocean area, because it's cool slowly in comparison to land. So the pressures conversely change according to temperature, and in night high pressure area arise on land and low pressure area arise on ocean. So winds are move from land to sea. So this is the simplest diagram of land and sea breeze which experience in coastal area. This is also the simplest way of understanding the winds system due to temperature differentiation. This is the valley and mountain breeze. Mountain breeze and valley breeze are the two related localized winds which occur in mountainous area. They are not the same as during the daytime. They are same as the sea breeze and land breeze. During the day, the sun heats up valley air rapidly, and this causes it to rise, causing a warm upslope winds. At night, the process is reversed. Mountain air is cools rapidly at night and falls downslope, causing a wind going to the other direction. So this is the situation of night, and this is the situation of day. Main wind belts. It's already we can see in maps the main belt or primary winds or permanent winds, also known as the permanent winds, which flow from same direction towards same direction. And these are the main prominent winds. First, the easterly trade winds in the tropics, the prevailing westerlies and polar easterlies. And another is the situation arises between movement of winds is the doldrum of ITCZ. So ITCZ or doldrum is the wind arise in the equatorial area. The doldrum are the region near the equator where the trade winds from each hemisphere meet, and this is also where you find the intertropical convergence zone. It is characterized by hot, humid weather with the light winds. Major tropical rain forests are found in this region, because this zone is very area of much maximum area rainfall area, and this ITCZ migrate north in the July and south in the January as sun moves their direction. This is the map of ITC location in January. ITC location January, it's moved towards south, because at this time sun overhead at the Capricorn, Tropic of Capricorn in southern hemisphere. The location of ITCZ in July is towards northward, because at that time the sun situation is reverse than January, because in June overhead sun is overhead on Tropic of Cancer. Another wind is trade winds. Trade winds are the winds that blow from the subtropical high pressure area. Generally all winds are move from high pressure area to low pressure area. So trade winds are winds those flow from subtropical high pressure area towards equator of low pressure zone. They blow from the northeast, because they change direction according to Coriolis effect, and in the northern hemisphere, and the southeast in the southern hemisphere. These winds blow almost constantly, and they are called the trade winds. Their name is very relating to trading ships. They gave traders gave their name and study because their routes always follow for their trade. So this name given by traders activity. Another wind is prevailing westerlies winds. It's also blow from subtropical high pressure area, but it's not towards pole. Its location is between 30 degree and between the 30 to 60 degree of latitude in both the hemisphere, and this wind blow almost continuously towards the pole. Because of the Coriolis effects, its direction change, and these winds appear to curve to the eastern direction. This means that they come from the west. So, since winds are named for the direction they come from, these winds are called westerly, because the winds come from the west direction. Their direction change according to Coriolis effect. They change their direction right in the northern hemisphere and left in the southern hemisphere. So their name is westerlies, called according to their direction. Westerlies are responsible for much of weather across the United States and Canada. Another wind is polar easterlies. Polar easterlies again the wind which blow from subtropical high pressure area towards polar high pressure area. Subtropical polar easterlies are winds as air over the poles cools and sink in the surface. As the air flow away from the poles, it is turned to the west by the Coriolis effect. Since these winds come from the east, they are called easterlies. And in this map, all the winds are located and their direction are we can see. So, winds is a very important role, and we already discussed. So, another factor is atmospheric moisture. Atmospheric moisture is one of the important element of climate, which found in different form as humidity, cloudiness, precipitation and visibility, or all are the symbol of atmospheric moisture. Atmospheric moisture is simplest name we all know as a humidity. Humidity is a general term representing the amount of water vapor present in the atmosphere. Humidity is very variable according to space and time. It ranges from nothing in cold, nothing it means zero in dry or cold Arctic region in the winter, and maximum as 4 to 5% of the given value of the atmosphere in the humid equatorial region. So, the maximum amount of humidity is available in equatorial region, and there is no humidity available in polar region. This variability is a greater importance for many reasons. The variability of humidity, how important for us? The greater the amount of humidity, the greatest is the amount of latent or potential energy stored in the atmosphere for the development and growth of atmospheric disturbance and storms. The amount and vertical distribution of water vapor determines whether an air mass will be stable or unstable and whether it resists upward movement. The amount of water vapor in a given mass of air is an index of atmospheric potential for yielding precipitation. By absorbing the earth radiation, it regulates the rate of heat loss from the earth and affect the temperature. After variability, it is very important to know what is the source of atmospheric moisture. Water is the chief source of moisture. So, it is very important to know what is the source of water. Water distributed among ocean, terrestrial and atmospheric reservoirs, but plenty of water supply is dominated by ocean, and it is about 97.2% of water in a salt form is available in our ocean. About 2.8% at the ground or surface, in which maximum in the ice sheets in the form of ice on ice sheets and glaciers. Groundwater availability is very low, 0.6 below 1%. Another availability of water available in the saltwater, freshwater lakes and saline lake inland, and their percent is very low, 0.03%. So, plenty of water is dominated by the ocean. Water is being constantly recycled. So, it is very important what and how much water where and how much of water available in different region. Water is being as recycled between the atmosphere, soil, surface storage, lake, stream, reservoir, glacier, plants, animal and ocean. All are very interrelated, or they are water circulate between all these processes, all these spaces through hydrological cycle, and all cycles whole hydrological cycles regulate by the nature of water to change their phases. All the water has a capacity to change their phase or their state. All the three phases of water is known as solid form, liquid form and gaseous form. So, through these phases water in the atmosphere is responsible for their existence. So, importance of water and their is very important for as a atmospheric moisture. It is a major element to energy balance of the earth. It forms cloud. It is a major reflector of the solar radiation. Through evaporation and condensation is a major means of energy transfer from the surface towards atmosphere, and at various places over the earth it is a very basis for precipitation. So, these are the very inherent importance. Three state of water is also already discussed, and these change according to their need, and when whatever is requirement is changed according to energy absorption and release of energy, they change their state. Water exists solid in the ice, liquid in form of water and gaseous form in water vapor. All these states whenever it change their state, it either absorb or release the latent heat. Heat is absorbed for evaporation, melting and sublimation. Other than latent heat is lost for condensation, freezing and deposition. This is the diagram. We can see the sublimation process is change water from gaseous to solid and solid to gaseous form. And in the evaporation heat absorbed, and at the same time in condensation heat release. So, evaporation is the cooling process, and heat both processes are opposite to each other. Freezing and melting is also, in freezing heat release and melting heat absorb. All by all three states water regulate in our atmosphere, earth surface and ocean, and this is very important for our climate system. Water transport the moisture to other region where it condenses into clouds. From clouds, rain and snowfall back to the earth surface, and this supplying a river which from back to the sea. And these all hydrological cycles going on. Water is a continuous cycle between these reservoirs, and sun is the very driving force for this. The entire process of maintaining constant water vapor contained by precipitation, evaporation, continuous precipitation is called hydrological cycle. Solar radiation is used to evaporate water from the earth's surface. By this process, lot of water is added to the air from all open bodies like ocean, lakes, rivers and soil. And this process is known as evaporation. Water loss also occurs from plants, leaves, their stems, and this process is called transpiration. Transpiration processes only occur on land surface, not in ocean. This is the model of hydrological cycle, and we can see how water flow from earth to atmosphere, and then atmosphere to ice cap region, and then earth surface in ocean and their groundwater. Evaporation and precipitation is a very important part of this hydrological system, and also a very important role, play a very important role in shaping climate. On the continent, the annual precipitation exceed above transpiration, when on the other hand, the sea annual evaporation exceed precipitation. Imbalance between the rate of evaporation and precipitation, as imbalance sun and energy over land and ocean is corrected by this imbalance equalized by the runoff and groundwater flow towards the ocean. Evaporation and precipitation are imbalanced at each latitude. Excess water vapor of the subtropical area is transported to the deficit area by wind, and water balance is kept on the earth, and then the atmosphere can contain constant amount of water. This is the graph show the how the mean annual precipitation and evaporation, they are not equal at all the latitudes. They are very imbalanced. Solid line shows the total evaporation. We can see dashed line shows of precipitation, which is maximum on 0 degree and minimum at 90 degree. So they have a gap between the precipitation and evaporation. Some space had gap are large, and some has gap different, but all this gap equalized by wind, and they transport water moisture from 0 degree to 20 degree and 30 to 60 degree. Both the cells are equalize this meridian distribution of transportation of water. Condensation and cloud formation. After evaporation in atmosphere, the process occur of condensation and then cloud form. Cloud are a visible aggregate of tiny water droplets and ice crystal, or a mixture of both in the atmosphere above the earth's surface. When air is cooled sufficiently by contracting the cooler air and uplifted, air temperature can decrease. It becomes saturated when 0 degree at 0 degree Celsius of temperature, and water vapor can condense into liquid or ice form. It may be rain, it may be snowfall. Formation of water droplets in ice crystal requires a surface of condensation, freezing and deposition. In the atmosphere, these surfaces are microscopic particles of dust, smoke and salt, commonly called condensation nuclei. Condensation is a process water vapor change into the liquid and solid particle in the atmosphere, and after that precipitation occur. A way of cloud formation is very important, because all these are act at are surfacing in a different way. There is no same process at a same place or a different place. Cloud develop in the air by following ways. These are the surface heating and free convection, lifting along the topographical barrier, wind speed ascent due to the conversion of surface air, uplifting along weather front. Now first surface heating and free convection. This process we can see experience in tropical area. When enough heating occurs, the air contacting with this hot spot becomes warmer and lighter than its surrounding, and hot air begins to rise, and then their air expand after some height and cools as it and then is ascends. When sufficient cooling has taken the place, saturation occur and form the cloud. Another process is lifting along the topographical barriers. Mountain, topographical and landscape play a very important role in rainfall. and experience, they can obstruct also in rain, and they also help to rain. For example, in monsoon area in our country, northeastern region experience much of rainfall, and also Western Ghat experience much of rainfall due to their orographic region, topographical region and situation of their mountain. So, this process act as a horizontal moving air cannot go through a large obstacle like mountain. So, the most go over it and force lifting along a topographical barrier is called orographic upliftment. And as the air rise along orographic or mountains and along the mountain slope, it cools, and the result of adiabatic expansion and form cloud. Another process is widespread ascent due to the conversion of surface air. Its situation is a rise in low pressure area, a cyclonic storm, and also very common in cyclonic area. A cyclonic storm system is the most common cause of this process. It associated with the weather front that separate air with contrasting temperature and density. The conversion of air in the lower troposphere initiate lifting and possible form cloud. Last process is upliftment along weather fronts. When two different air masses, when one is cold, it may be cold and it may be hot, and it varies their temperature differences. They have two types in nature. So, two different air masses come together. Mostly one of air mass is warm in comparison to other and moist, while other is cold and dry. The leading edge of the cold air masses act as an inclined wall or front and causing the most warm air to be lifted upper in the sky, and it cools due to expansion resulting in saturation and clouds form. Precipitation, after cloud formation, precipitation is occur. Precipitation is any form of water droplets or particles, and it may be solid and liquid, develop in the saturation atmosphere and falls to the ground from clouds. Falling rain, snow, sleet, hail are referred to collectively as a precipitation. Water droplets and ice crystals can only fall to the earth's surface if they grow to size and that can overcome updrafts. But cloud droplets grow through a following process also. These are two important processes: collision and coalescence process and ice crystal process. Collision and coalescence process of precipitation is this. In this process, cloud are called as a wire cloud and consist of water droplets. Warm cloud and consist of a water droplets. Droplet size in the cloud must be variable because condensation nucleic in nature cannot have same size. Larger and heavier droplets fall faster than lighter and smaller droplets. So, larger and heavier droplets can capture lighter and smallest droplets by collision and coalescence. If their size are increased to overcome natural updraft, these raindrops can fall down to the ground, and rain developed by collision, and coalescence process is called warm rain. Another process is ice crystal process of precipitation. This process is to form raindrops. By this process, water droplet and ice crystal must coexist in the cloud. In this cloud, water droplets only in the lower part and ice only in the upper part, because water is density is low than the ice particle. Water and ice mixed in the middle part of the cloud exist. This is known as a cold cloud, and this is grow due to the difference vapor pressure between ice crystal and super cooled water droplets. Ice crystal grow larger at the expansion of surrounding water droplets. After increasing the size by the deposition, these are the growing rapidly by colliding with ice or water droplets. Rain developed by ice crystal process is called cold rain. Global distribution of precipitation is not it's very result of the whole the process of temperature, pressure, wind motion and moisture condition. The global distribution of precipitation is closely related to global circulation of the atmosphere, distribution of land, sea and topography. All factors combinedly affect and influence the global distribution of precipitation. Precipitation is most abundant where the air rise, like equatorial region, and least abundant where it sink at the 20 to 30 degree subtropical region, where the sinking air sink. This is the map show the total distribution pattern of rainfall at global scale, and you can see there are different zones of rainfall from equator to poles. In the whole global, if we generalize the picture of rainfall, the highest rainfall occur in equatorial region, because here rain is formed due to conventional, and here the sun is overhead throughout the year. So, whole year throughout the year rain is occur. As we move from towards equator from 20 to 30 degree of mid latitude tropical subtropical region, at where the descending air and high pressure area located, this is the lowest rainfall region, and all this is the lowest rainfall region, but here the evaporation rate is very high. So, all the desert are located in this region 20 to between the 20 or 30 degree western side of continents, not receive more rainfall. Some eastern side of due to the trade winds, eastern side of continents receive much of rain in comparison to western side. So, second important high rainfall zone is the mid latitudes of 40 to 50 degree. Here rainfall due to the cyclone and westerly winds, and also pole area receive a lot very less of precipitation water in the form of snowfall. So, zonal distribution of precipitation summarized according to their factor and their ability of the occurrence of rainfall. In tropical region, constant solar heating encourages convection process, and the trade winds converge along ITC jet intertropical convergence zone, producing rising air, towering clouds and abundant rainfall all year long. In the and this area situated between 0 to 10 degree of north and south of the hemisphere. In the mid latitude, precipitation is governed by the prevailing westerlies and subtropical anticyclonic rain. In the cold air of polar region, precipitation generally decline as lower temperature reduce the mean saturation vapor pressure. Mountain ranging near where the mountain orographic situation is available, water source can receive high rainfall, because orographic upliftment and sharp reduction in rain on the leeward side, windward side receive the much of rainfall in comparison to leeward side. Leeward side slope of rain almost 0. So, these are the factors which play a very important role in shaping the atmospheric lighting in my point of view, and these I want to conclude this all these factors. Generally, climate is a source of energy and water. In this mechanism, export energy from region to surplus to region of deficiency. Atmospheric circulation is driven by the horizontal heat gradient between the equator and the poles, and operates to correct the imbalance by the poleward movement of it. Circulation system is largely manifested in several atmospheric cells and various winds belt. water has a number of unique attributes that enable it to play an important role in the climate of the earth. So, water, wind, atmospheric circulation due to the pressure gradient and temperature all have played a very important role to shaping climate of earth's surface. Thank you.
Right, thank you so much ma'am for this lecture, and of course today, as ma'am already summed up for us, we have talked about the two factors of wind and moisture. So, with respect to that, as you were going through your points, I would like to raise a few doubts. Perhaps you could just tell us once more, just briefly, what would be the hydrological cycle?
Hydrological cycle, flow or transfer, moving of water from Earth's surface to atmosphere.
Okay.
In the between all the reservoirs, also ice cap region of mountainous area, underground water, lake, streams, all are the part of this system. So, main is the water transfer from land to atmosphere,
right,
and atmosphere to land.
Okay.
So, in this process, the attributes of and changing phase of water in different form, gaseous, liquid and solid, they play a very important role in transforming this water in hydrological cycle.
Okay, so you call this a cycle because of course there is taking up of water
starting from one to another.
Yes. So. Right. Also, we often talk as a lay person that we could see clouds in the sky, but no rainfall happened.
Yeah.
So, is there always a chance that when such a phenomena occurs, there is going to be a rainfall?
Moisture, ability of moisture is very important, because how much is moisture available in atmosphere?
Okay.
It depends.
Rain
depends on
moisture. Okay. All right. Yes, that's a very interesting idea to know. Also, ma'am, you talked about different ways of cloud formation. Which is the most common way of cloud formation?
Conventional is common, because whenever this area heat up and feel we warm in in this season, summer season, we feel very warm air moving.
Yes.
Afternoon, as in summer in afternoon, we feel and we also talk. It may be rain in evening.
It may rain, yes.
It is the conventional type of rainfall.
Right.
So, it is the very common phenomenon, equatorial, but also where the tropical region are located, like country of India.
Okay, okay, ma'am. So, just lastly, I just want to ask you, what is surface heating and what is free convection that you talked
surface
about?
Heating is the heat up
surface of the earth
through sun rays.
Okay.
Okay. And convection is arise the air, because when the temperature is low, air is also very high, low density,
right.
And they move, they very easily move towards upper atmosphere.
Right.
So this is the rising air.
Okay.
Rising of air.
Okay, wonderful, ma'am. And just with these questions, I don't have more to ask, and of course everything else has become quite clear for us and also for our viewers. So friends, this was our two-part lectures on climate and controlling factors. With this, we would like to sign out, and of course, thank you for watching, and thank you, ma'am.
Thank you.
Thank you, viewers. Have a great day.